So last time we talked about the sequential StreamGang example, and I'd shown you how to write the process stream and process input methods using a sequential stream, and it was very simple to do that. What we're going to do now is we're going to talk about how to implement the print phrases method, which is going to take the results of process stream and then output the results. And as you'll see, it does some pretty cool things. And we'll talk about the cool things it does. It uses some interesting features, particularly flatMap and groupingBy. And I'll talk about how all that stuff works. And you can download you can find the file that we're talking about here in this repository. Yeah? Everything up through today, that's correct, yeah. OK, so let's talk about how to visualize the code we're about to look at. Here's basically what the program does. So assuming you've got all the works of Shakespeare and you've got a long list of famous phrases that he may have said or not, you want to go find where those famous phrases appeared in the works of Shakespeare. So this is a little snippet of the output. If you give a large amount of phrases, then it'll go through and it'll print out for each work, for each play, for example, like Hamlet, it'll print out the various phrases we were interested in looking for, and it'll tell you the character offset into the play where the phrase occurs. So, neither a borrower nor a lender be appears at this location as an offset. Brevity is the soul of wit, all sort of from the same bag of cliches that Polonius gives to Laertes. And the example we're going to see here, print phrases, that generates this output. For each play, it'll give the things that come out for that play, the phrases that come from that play. We're going to show how the flatMap and collect groupingBy aggregate operations work. But first, we'll kind of visualize what it looks like, and then I'll show you the detailed code. So if you recall, the process stream method returned a list of lists of search results. That's what it came back. And so for every work of Shakespeare, for every play, for example, there was a list of the phrases that may have appeared in it. And so what we're going to do is the print phrases method is going to take this list of search results as input, and it's going to go ahead and convert it into a sequential stream. So now we'll have a sequential stream of lists of search results. And then we feed that stream of lists of search results into the flatMap operation. And flatMap is a really cool functional operation. It goes by some other names in other languages, but flatMap is what they call it in Java. And what it's going to do is it's essentially going to flatten the stream of lists of search results into a stream of search results. And we'll talk more when we look at the code how and why that has to take place. And so what we end up with is this stream of search results, because we had a stream of lists of search results before. Now we have just a stream of search results. And we feed that into collect. And collect, as always, is going to trigger the intermediate operation processing, in particular flatMap. And it's going to apply the collector, which is the groupingBy method. And the groupingBy collector is going to create a map which will group the phrases according to the plays where they appear. So the map will be a mapping of string to list of search results. And so we're going to have the string be the name of the play or the name of the work, right? So Hamlet or Macbeth or whatever. And then there'll be a list of search results, which will be all the phrases that appeared in that particular work. So notice how we're rearranging things to get the results in the order that we want them to appear. So let's see how we would actually implement this in Java 8 code. And so remember, this is sort of what we're doing at a visual level. And now here's the code itself. So print phrases is going to take this list of search results, and it'll use a stream to arrange them in the right way and then print them. So first thing it does, this is pretty simple. We just take the list of results, which is what comes in as a parameter, and we turn it into a stream. That's just a good old-fashioned factory method, nothing tricky there. So now we've got a stream of lists of search results. And of course, that list, the list of the search results will be the search results for each input that we had. And then what we're going to do is we're going to flatten everything. So we're going to use the flatMap operation, and we're going to pass it the list : stream factory method. And what that tells flatMap is to take this stream of lists of search results and turn it into a flattened stream of search results. And the reason we want to have it a flattened stream of search results is then, well, I'll have to explain why we want to do that in a second. The reason we want to do it is because then we can use collect. But the way that flatMap works is flatMap is a really interesting method that can have an output stream that either has more items than were given to it, an equal number of items that were given to it, or less than the number of items that are given to it. So it's really the most flexible of the different approaches, because you can get back sort of a whole bunch of different kinds of results with flatMap. Recall that with map, you only ever get back exactly the same number in the output stream as you had in the input stream. So map is just a transformation, but it always gives the same number of items back. Remember, filter gives back less than or equal to the number. And if you also recall, with map, you can transform the types, and with filter, you cannot. So flatMap is interesting because you can both, reduce things or increase them or give back the same number, and as we'll see in a second, you can also do transformations. You can also transform the types as well, as we do in this case, because we take in a stream of lists of stuff, and we get back a stream of stuff. Question? How can it give it less results? Because it might end up deciding to get rid of things. It might only give you back a few. Discarded? Well, it all depends on what how flatMap is programmed, what it does, what kind of types it. Maybe it takes us something and it returns, a reduced number of them. You can omit things. flatMap doesn't have to give you back the same number. In this particular case, what it does is it goes ahead and will give you back more, right? So if you end up giving it, say, 38 lists of search results, it will give you back a stream of search results which could have a flattened number. So it all depends on how it's programmed. So it can give you back different amounts, and it can also change the types, which it does here. In this case, it gives you back more, and it also goes ahead and does the transformation. The next part, yeah, Allison. You would usually you use map. flatMap is what you do typically when you want to sort of smush things down and flatten them out. So in this particular case, we want to end up with a stream of search results, and we took in lists of search results in our stream. And so we know we want to combine them all together. So we're going to end up using the groupingBy method to group things. And this is what's cool about this is groupingBy has a bunch of different parameters. This particular one is going to take a classifier, and it's going to group things according to title. So what it's going to do is it's going to take in the stream of search results, and it's going to group things that have the same title, and that's going to be the key, so it'll be the string. In this case, the title is the name of the play. And then the results here, if you just give one parameter, then it just takes everything that matches that key and it sticks it in a list, which is the value part of the map. So groupingBy creates a map. You can specify what kind of map. You can have a tree map, or by default it'll use a hash map, but you could have a tree map if you wanted to. We don't need a tree map here, but you could. And so it's going to group things together using the classification function, which is this method reference, which gets the title of the work and uses that as the key to the map. And so that'll, of course, trigger the intermediate operations, and it'll go ahead and then return the results as a list of search results. So again, I always like to think about this in terms of grouping stuff like the silverware drawer that you have to organize your forks and your knives and your spoons. It just puts them in the right bin. What we end up with is this map that associates the phrases in the input with the titles where they were found. And then once we have that map, then we can go ahead and print the results. Now, I could have, kind of chained all this stuff together had I wanted to. I could have said list of results.stream.flatmap.collect.forEach. I could have done it if I had wanted to. That would have worked fine. But it would have been a little bit harder to explain because you would have lost the fact that collect is returning a map. That would have been a little bit less clear syntactically from looking at the code. So I broke it up a little bit more coherently than maybe I could have done if I was trying to make it as concise as I possibly could. So what forEach does on a map is it iterates through the map for every element, and what it gets back is essentially gets back a map entry, which we can represent here using type deduction. So we don't have to say map.entry. We can just say key, comma, value. And so that's what we get back is a key value pair. And then what we do is we are going to iterate through every key value pair in the map. And for each key, which is the title of the play, we print out the title. So, Hamlet or Macbeth or Julius Caesar or whatever. And then we're going to say, contained. And then after that, we're going to take the value. And the value in this case is a list of search results. And for each search result, we're going to go ahead and print out the search result, which would be, in this case, the phrase that we were going to be looking for with the location where it occurred in the input. Okay, so that's basically just showing how you can do this. And this is really cool. I think it's really cool because it's so concise. So we take a list of lists of search results, we stream it, we flatten it, we collect it into the right groupings, and then we just iterate through there and print it. And there's probably even more concise ways to do this using Java 8, but I figured this was a pretty good example. If anybody can think of a better way, let me know. I'll make it even more concise. But it's very powerful, very pithy, and therefore good once you understand how to read it. Okay, so that's the end of part 2, just kind of giving an overview of print phrases, which is really just an excuse to talk about the flatMap operation as well as the groupingBy operation.